This video tutorial looks at the mathematical strand of number, and more specifically we're going to focus on direct proportion. So what is direct proportion? Basically, direct proportion means that there are two things or two variables that are in the same ratio. So effectively, if you multiply one of them by a number, all right, it results in the other one being multiplied by the exact same number. Okay, so if one gets bigger, the other one is going to get bigger by the exact same amount, or if one gets smaller, it's going to get smaller. The other one's going to get smaller by the exact same amount. All right. If two quantities or two variables, all right, or two things are directly proportional, then we write them using our little cursive kind of arrow thing there. Okay, kind of looks like an at, but all right, that means so this symbol here means directly proportional. All right. If things are in direct proportion or directly proportional, then they must be multiplied by a constant of k. Now k is called a proportionality constant. All right. And k is actually the gradient of the graph of those two variables if you were to do that. So for example here, if we look at our graph, we've got some points 0, 0, and we've got here 25, 200, and we've got here 50, 400. So the points 0, 0, the points 25, 200, and the points 50, 400. Now, we know the distance of m is directly proportional to the distance of s in this particular graph. Okay, the distance run is proportional to the time in seconds. So that means that m must equal ks, and k represents our constant called the proportionality constant. All right. In this particular activity, if you were asked to find out what k was, all right, you would just substitute one of these points in. So let's use the point 25, 200. I'm going to put that into our equation. So we end up with 200 equaling k 25, all right, or 25k if you really want to do that. K would therefore equal 200 divided by 25, and k would equal 8. So you'd write therefore m is equal to 8 lots of s. Okay, so the meters gain is 8 times the seconds. But we know that m and s are directly proportional because the graph is a straight line and it passes through 0, 0. So here's some examples. Again, we've got another graph here. I'm going to plot these points. So remember, plotting points, I've got my x and my y values. They make up the coordinates that we want to plot. So let's do that. So 2, 5 is one plot. 3, 7.5 is another one. 5, 12.5, which means it would be 4 to 10, which would be there. And then we can see that if it was 1, it'd be 2.5, which is about there. All right, that's going to be the graph that we're going to plot. Okay, now obviously I can't fit some of the other coordinates on this graph, but I've got my straight line. So it says determine if the following table is in direct proportion by plotting the graph and finding the proportionality constant. Again, we know it's a straight line, so that means direct proportion. We know it passes through the point 0, 0. So again, direct proportion. Now we just need to find the proportionality constant. So y is going to be in direct proportion to x. Therefore, y must equal our constant times by our x. I'm going to now put in a set of coordinates. Let's choose the first one. That's pretty easy. Therefore, 5 must equal k lots of 2. All right? Or if you really wanted to write it, you could write 2k. Therefore, k is going to equal 5 divided by 2. So our constant is 5 divided by 2. Now, therefore, we can write, well, that's essentially what we've done. If we wanted to then rewrite the equation again that connects x and y, we would say y equals 5 over 2x. Okay, if you're given an example where you've got two variables that are in direct proportion and you need to work out one of those variables when given the value of another. So for example, looking at the little box here, we can say that we've got y is proportional to n, and when y equals 40 and n equals 3, find n when y equals 137. Now, we can use a formula, all right, or we can use a multiplier. Formula method. Formula starts like this. We know that y is directly proportional to n. Therefore, whoops, I better write an actual therefore symbol. Therefore, y must equal kn. And if y is 40, that must equal k3, or 3k. That means that k must be 40 over 3. If k is 40 over 3, we can substitute that back into our formula, and we can say, therefore, y equals 40 over 3 n. Now, we need to find out what n is when y is 137. So we now substitute that in, and we go 137 equals 40 over 3 n. I'm running out of room, so I'm going to bring it up here. Then I'm going to rearrange that. I'm going to end up with 137 times by 3 over 40 equals n, and n is therefore going to equal approximately 10.275. Or we can use the multiplier method. Alright, so we know that 40 is to 3 as what 137 is to n. Alright, so we need to find out what did we multiply 40 by 137, because whatever we times by there, we've now got to times by over here. This is the multiplier method. We need to find the multiplier. In order to work out what the multiplier is, we divide 137 by 40. That gives us our multiplier. Which is 3.425. We then times 3.425 by 3. That gives us an answer of 10.275, and therefore we can say that n equals 10.275. Okay, two different methods, same answer. Okay, so here's a practice question I'd like you to have a go at regarding direct proportion. Please feel free to pause the video, and when you think you've got the answer, please continue the video and we'll see how you went. Okay, so the question was, the speed of a falling object is directly proportional to the time for which it falls. So the speed is directly proportional to the time. The speed after 5 seconds is 49 meters per second. How long will it take for the falling object to reach a speed of 100 meters per second? Now I'm going to use the formula method, okay, and we'll see if we get the right answer. So S equals KT. Now it says the speed, okay, is 49, so I can put that in. 49 equals K lots of 5, because that's the time, is 5 seconds. So therefore K must equal 49 over 5, or 9.8. You can write, that's fine. Now if I want to find out how long it will take, so the time for 100 meters per second, I can just use my formula again, but I've substituted K in. So I've got S equals 9.8 lots of T. We're looking for the time, so we know that the speed is 100 meters per second. So therefore T must equal 100 divided by 9.8, and T will equal approximately 10.2 seconds. Now if you wanted to do the multiplier method, you'd have 5 seconds is to 49 meters per second, which X is to 100 meters per second. Okay, so what you would do here is you go 100 meters per second divided by 49, Alright, then you would times your answer by 5. That would give you x. If you were to do that in your calculator, you would get x equaling approximately 10.2 seconds.